We are continuing the tutorial on past questions on logarithms that has come so far under WASSCE and the SSCE. In this episode, we are taking the question from WASSCE 2011, which was the first question in section B, elective mathematics paper, which is the further mathematics. Given that the log 3 log m base 2 is equals to n, and the log of 4m base 2 equals to n plus 4. We have to find the values of m and n. So we are just going to apply the laws of logarithm and see how we can manipulate our way from log to indices and find m and n. So in this case, the first log is 3 log m base 2 equals to n. We can see right away that we can apply the third law, which is the number multiplying the log become an exponent of the argument, meaning log m exponent 3 base 2 equals to n. So now from logarithm we can also convert to indices, making the base being the base of the indices, taking the number as an exponent equals to the argument, meaning 2 exponent n is equals to m exponent 3. So now we are in indices. We don't have any much to do. So let's label this as our first equation. Then move into the second logarithm, which is the log of 4m, the base of 2 equals to n plus what? 4. If that is the case, what are we going to do? We are also going to apply the same principles from logarithms into indices. The base, the number, the argument. So I'll be having 2, the exponent of n plus 4 equals to 4m. Right? 2 is taking this as an exponent. Then moving into logarithm into indices. We know that if I have the powers being added, it means the base were previously multiplying. So I can also rewrite this as 2 exponent of n times 2 exponent of 4 equals to 4m. So what am I seeing? I am seeing that I have n exponent 4 here, which we can see n exponent 2 exponent n, which is also here. So we can see that we can do substitution, but it will be easy if we eliminate this 2 exponent 4 so that we have the n 2 exponent n isolated so that we can equate easily. So this will further become 2 exponent of n times 16 equals to 4m. What do? We need to clear this. We divide both sides by the 16. So we're having 2 the exponent of n equals to 4m divided by what? 16. I guess that could be easy. So if that's the case, 4 is common to both 4 and 16. So I'll be having 2 exponent n equals to m divided by what? 4. Which this could also be our, let's say, equation. Okay, we can take it as equation 2. This is the final stage. So from equation 1 and equation 2, we can substitute the value of 2 exponent n. 2 exponent n. We can equate equation 1 and 2. So equating equation 1 and 2 simply means that whenever I see 2 exponent n, I write this is the same as this. So we have our m exponent of 3 equals to 4. Is it 4? No. It is m divided by what? 4. Okay, what do we do further from here? We can cross multiply, right? Good. So let's cross multiply and have 4 multiplying that to give us 4. M exponent 3 equals 1 times m. That is m. Okay. We are having m at both sides. What do we do? Okay. Let's divide both sides by what? M and c. If you divide both sides by m, you'll be left with 4m squared equals to 1. Do you see that? If you divide both sides by m, this m divided by m with 1, it will cancel here. So let's send back our 4 to make our m squared equals to 1 over 4. We could have done the same thing here by dividing both sides by m to have our m squared equals to 1 over 4. But it is clearer in this form. So what do? We need the m. So we find the square root of both sides. Meaning m will be equals to plus or minus the root of this, which will be 1 over 2. Plus or minus. But let's see whether we need a negative. The argument is m. M is the argument. So we cannot have a negative number as the argument. So we discard the negative aspect and pick the positive. So m is 1 over 2. Then we need to find that of the n. In which of the equation can we pick? Okay. We can pick here, or we can pick the first equation. Let's pick the first one. So let's use the different marker. So we have put m equals to 1 on 2 into equation 1, meaning I'll be having 2 exponent n equals to m, which is 1 over 2 raised to the power 3. And I guess the laws of indices can come to play. The 3 affect the 1, affect the 2, meaning 1 over 8. Then if it is 1 over 8, it will be 2 exponent of n equals to 1 over 8. Okay, let's make it this way. 1 over 2 exponent 3, where the reciprocal of this can become 2. Then we change this to become negative from the properties of indices. So I'll be having 2 exponent of n equals to 2 exponent of what? Minus 3. Can you see that? We have the same base. So we equate the exponent. Let's see if our red marker can help. So from here, we can say that we are going to equate the exponent, meaning our value of n is going to be a negative 3. Can n be negative? Let's find out from the logarithm. Okay, the argument, we can get a negative number because 2 exponent negative number will give us a fraction. Here, okay, we are having n also at the other side. So n can be negative. So we have our n to be negative 3. Then we have our m to be half. So that's the value we are looking for both n and what? N. We can also pass through a different means to get the answer without changing into indices. We can move directly with logarithm. We will try that in the next episode. The same question, a different approach. So don't miss this. Come back to watch that episode also. Thanks for watching. Bye-bye.